Hello and welcome to your lesson on scatter graphs. In this lesson, you will need to draw and interpret scatter diagrams and recognize positive and negative correlation. So, a scatter graph shows the relationship between two sets of data. The relationship is called correlation. It is important to remember that correlation does not imply causation. So, for example, the number of firefighters at a fire usually increases as the fire spreads. Although there is a positive correlation, meaning as one increases, so does the other, there is not causation. Bringing more firefighters to fight the fire does not cause the fire to increase the spread. Okay? So a positive correlation occurs when both variables are increasing. For example, the taller you are, the heavier you are likely to be. If the points are nearly in a straight diagonal line, a little bit like this example, okay, there is a strong positive correlation. You'll also see examples where it's probably even better than that, and you've got quite a few points that look a bit like this, okay. There won't be quite as many outliers. See these dots here where we can't really see if they're positive or not? They're called outliers, and there's not usually quite as many. You want to try and draw your line of best fit in between as many points as possible, so try and get it right in the middle. Okay, I'm going to show you some examples in a moment. So, like I've just mentioned, a point that does not fit in with the pattern of the data is known as an outlier and can be ignored if it's thought to be due to an error in measuring. So we've got quite a few in this example, and you won't normally get that many. Okay, you'll normally see quite a nice positive correlation, a little bit like this one. A negative correlation occurs when one variable increases, the other decreases. So, for example, as the temperature increases, the sales of woolen hats are likely to decrease. Or as the temperature increases, the likelihood of hot chocolates being sold will decrease. Or it could be the other way around. As the temperature decreases, the number of hot chocolates being sold will increase. Okay, again, this one, there's quite a lot of outliers, such as these over here, which don't really match up. So again, you'll probably get a correlation. A negative correlation looks a little bit more like this one, where you can quite easily put in your line of best fit throughout the middle. So remember, middle for your line of best fit, and your negative correlation is going this way. Okay, so it's pointing downwards, negative. And then if I draw you another positive one, you can see the difference here. Okay, positive going up that way. All right, so remember that because you'll be asked about correlation. And just make sure your line of best fit is in the middle. Now then, a zero correlation occurs when there is no linear relationship between the variables. For example, there's no connection between the height of a person and their mathematical ability. Okay, so that's usually when you've got lots and lots of dots all out of place. Okay, we don't really have a correlation, and you wouldn't actually need to draw a line of best fit. You can draw a line of best fit on a scatter graph that shows positive or negative correlation, and as I've already mentioned, it is drawn as close to all of the points as possible, with approximately half the points above the line and half the points below, so in the middle. Okay, some people try and join the lines that join the dots and they think that's the line of best fit. It's not. You need to do the line in the middle. You can then use the line of best fit once you've drawn it to estimate the value of an unknown variable, okay, from a known one. So that means that if you know someone's score in the 100-meter race, you might be able to predict their score in another sport, depending on the graph. Predicting a value that is within the range of the data is called interpolation, okay? This is accurate, all right? So basically, if I had a graph and I had a bunch of points, all right, and I had a line of best fit, and I thought, okay, well, here is what shall I use? A dance class score of 50, and here is a gymnastics class score. So dance is on this side, and gymnastics is on this side. Okay, I can say that in dance, if she scored 50, I can go across to my line and go down to my gymnastics grid, and I'll be able to take a measurement from this axes here to give me a score for gymnastics because there's a positive correlation. Okay, because I'm using the line of best fit, I am extracting information from data that's already there, which is why it's called interpolation. And it's more accurate because I'm using data that's already been given to me. However, let's say the highest that the gymnastics scores went up to were 100, and I wanted to know something that was somewhere around here. Okay, that's where you're predicting a value that falls outside of the data that you've collected and is called extrapolation. Okay, so these predictions are generally less accurate. Now, a question might say something like, what would the value of a car be at 10 years old? And if your graph doesn't give you the information for 10 years old and the question's asking you, that's extrapolation. And what you would say there is that there is not enough data. Okay, there is not enough data, or it's not safe to extrapolate. Extrapolate. Okay, now here's a really good example of a scatter graph and a few questions that you might get asked. Now, if you look at the graph, before I put any questions up, we can already tell a few things from this graph. We can see that it's a positive correlation. Okay, we can also see that it gives us the maths and science scores. Okay, and we can see that a line of best fit has been drawn. Okay, questions then. The scatter graph below shows the percentage scores of some students in science and maths. A line of best fit has been drawn. What type of correlation is shown in the graph? Okay, well, I've already gone through some of this because I wanted to pick out the information. So we already know that it's a positive correlation. We know it's positive because it's going up like this. And what it means is that as your scores go up here, the scores also go up here. Okay? Question B says, a student was absent for the maths test but scored 30 on the science test. Estimate her score for the maths test. So what we do, it tells us the science test score, okay, and it was 30. You can see that it's been done on the diagram anyway. So what we do is we go across to the line of best fit, and once we hit the line of best fit, we go down to the maths score, okay, and that looks like it's about 16%. Okay, so not very high. It could be 18. But it looks a little bit, I'm not sure, maybe 16. Okay. Also, you will be allowed to have a range of answers, so it might be between 15 and 18. Okay, so don't panic if you put 17. They will let you have a bit of a leeway because of the estimation aspect. It then says a student was absent for the science test but scored 50 on the maths test. Estimate his score on the science test. So again, this time we're going to go to the maths test because it tells us that they scored 50. We're going to go up to the line of best fit and across once we hit the line of best fit to the science test. And there it looks to me about 53%. Okay? So that is a kind of way that they'll get you to answer questions based on scatter graphs and correlation. Now, another type of question that will come up is to draw a scatter graph. Be very careful when you're reading the questions. I've been looking at some of the exam papers and some of the students have been getting confused, trying to draw too much. So, for example, there was a question about hot and cold drinks and they thought they had to draw the graph to show hot drinks, how many were sold, and cold drinks, how many were sold. And there was just too much information. But when you read the question carefully, it only asked for the hot drinks. So just make sure you're reading your questions very carefully. Now then, as well, it won't always give you the axes. I've put the axes on here to make it easier, but it won't always, by axes, I mean the grid, the drawing of this, okay, and your values here. Okay, it's up to you to decide on the best way to draw this. So because I've got like 38, 62, 18, 75, 38, 59. Okay, so you've been given some maths marks and some English marks, and you've got to plot them on the grid. Okay? So basically, I've decided then I'm going to go up in tens because I've not got anything higher than 100. I've got a lot of 2s in there, which means they're even. Okay? And I can just estimate where they're going to go. All right? So what I'm going to do is I'm going to go to my math score. Okay? And for each one, I'm going to go 38 across and then 74 up. 62 across, 44 up. And what you're doing is you're plotting the 2 marks and whether we're going to get a positive or negative correlation. So 38 across for the maths mark and 74 up for the English mark. So again, it's not got to be perfect, and you'll probably get a grid with smaller lines as well, like this. So it might be easier for you in the actual exam. Okay, so I'm going to do 38, about there, 74, about there, okay? 62, 44, so 62 across, can you see I've gone to 62 about there, 44 up, about there, okay? 1885, so if you want to fast forward me, you can. 75, 19, 38, 88, 59, 69, 66, 50, 92, 33, 52, 29, 75, 34, 48, 56. Okay, done. Right, so what can we see from this then? Now, I've not got a ruler that I can use here, but I'm going to try my hardest to draw a line of best fit. You will use a ruler, okay? You must use a ruler because you're doing this on paper. Well, you might do it online, but you might be able to draw a line of best fit. They might have it there for you. Remember, you've got to try and get around about half of the dots on one side and half of the dots on the other. I'm going to maybe do it a little bit. Sorry, it's because I'm using my ruler and you can't see that I'm using a ruler. Okay, so I've tried to get 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, maybe a little bit further that way. Okay, you'll see what I mean in a second now that I'm going to draw it. Here we go. So I've drawn a line of best fit. I've put my line going through that point. Okay, but we can see I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then that one's bang in the middle, so that's fine. Okay, so that's my line of best fit drawn. And I can actually see there that we have a negative correlation, which does usually happen with English and maths actually. You know, if you're better at one, you're not as good at the other. All right. So, however, there is a student here who's quite good at English. He only got 40-ish, well, I think it was 38, wasn't it, in the maths. This one here is not too bad. He got 69 and 59 and 69 in his. Okay, so that's not too bad. He's doing kind of well. But the further we go here, like the better you do in maths, not as well in English. Okay, so he got 92 in maths. Okay, but only 33 in English. Okay, it's this guy. All right, so we can see that that's a negative correlation. We can also say that if somebody, now we can use our line of best fit, remember, and we can say that if somebody gained 50 marks in English or 50% in English, what did he get in maths? We can go across from English, which is here at 50, across to our line of best fit. Sorry, I went a little bit over, down to maths, And to me, that looks like it's about 62, 63, 62% in maths. So we can use our line of best fit to answer questions, and you will be asked to do that. So you will be asked to draw it, and then you'll be asked to answer questions. But I'm feeling very confident about that, and I think you should too, especially after going through that example. You need to just make sure that you do your axes correctly. You can't just write the data. You see here where you've got 38, 62. You can't just write them in as your numbers to go up here. Okay, it has to be in an order. So you could be going up in 2s or 10s or 5s. It depends what data you get. Okay, 10s was the easiest option here, and you are just estimating when you're putting in your points. Okay, so don't panic. I mean, sometimes you might get it where it's really easy, and because you've got these little lines that they give you, sometimes they give you grids with extra little lines, it might even be easier. Okay, so you get something that looks a bit like that, and you can actually, go up in a certain amount of numbers, but you've just got to be very careful. Okay, so, sorry, I didn't even put the question on, but I explained it. 11 students scores out of 100 on their maths and English tests. Plot a scatter graph. Okay? Right, so hopefully you feel more confident now with drawing and interpreting scatter diagrams and recognising positive and negative correlation. Okay, so well done. I am really looking forward to seeing you again next time and seeing how well you do on your assignment based on this.